Hi all, so welcome to another Geo Tech Talk session. So today I will talk about Elasticsearch. Okay, so this will be the outline of my presentation. So first of all, what is Elasticsearch? Elasticsearch is a distributed open source search and analytics engine for all types of data, including numbers, texts, structured and unstructured data. And Elasticsearch is built on Apache Lucene library, which is in open source library. And Elasticsearch is associated with a set of supporting tools that supports Elasticsearch for data ingestion, enrichment, storage, analysis, and visualization. So I'll be talking about some of these tools later in my presentation. And Elasticsearch index. So basically, Elasticsearch index is a collection of documents that are related to each other. So these documents are stored in JSON format. So I will show that you during my demonstration. So here, as shown here, each index is split into several partitions called shards. So this has been done that so that these shards can be stored in multiple computers across a cluster of computers. So basically to achieve the distributed nature. And all these documents are hashed into a particular shard. So that means, let's say, we want to insert a document into Elasticsearch. So what happens is, what Elasticsearch performs a special hash operation on the document and decides in which shard that document should be placed. As I said before, each shard may be on a different node in the cluster. The Elasticsearch basic high-level architecture. So Elasticsearch is distributed by nature. So here in this example, we have an index with two primary shards and two replica shards stored in a cluster of computers with three nodes. So what is the use of these replica shards? Let's say the node 1 goes down for some reason, but we don't have anything to worry about because there's a replica of node 1, shard 1 in node 2. So that replica shard will automatically become the primary shard in case of a node failure. So when we are writing something to Elasticsearch, first it will route it to the primary shard and then replicated into replica shards. And when you are reading from Elasticsearch, it can be done from either a primary shard or a replica shard. Okay. Then inverted index. So Elasticsearch is optimized for full text search. So inverted index is the basic concept behind that optimization. So I'll explain that with an example. So here we have 4 documents, 1, 2, 3, and 4. So here what we have done is we have listed down all the unique words in these documents, and the document number of the documents which is that each word occurs. So this example, if we take word row, it occurs in document 1, 2, and 4. So let's say someone searches for the list of documents that contains the word row. So we can easily do that using this method. It's pretty easy. But let's say someone wants to find the list of documents that contains the phrase robot. How can we do that using this mapping? So we can easily eliminate documents 3 and 4 because those documents doesn't contain the both words row and board. Then we'll have to recursively go through all the remaining 2 documents to find whether they contains the phrase we are looking for. So it's a doable thing, but is it the best way of doing what you want? This is where the inverted index comes in. So what we have done here is, additional to the previous table, we have recorded the position of each word in each document. So as example, word row occurs in document 1 in positions 0, 1 and 2. So let's try to find whether these documents contains the phrase robot using this mapping. So in this case as well, we can eliminate document 3 and 4. So let's try to find out whether document 1 contains the phrase. So in document 1, positions of word row are 0, 1 and 2. So in order to form the phrase robot, the word bot should be located in either positions 1, 2 or 3, but it doesn't. It's located at position 4. So the document 1 doesn't contain the phrase we are looking for. And if we take document 2, positions of word row are 0 and 2. So in order to form the phrase, word board should located at either position 1 or 3, and it does. It's located in position 3. So now we know that document 2 contains the phrase we are looking for. So that is the very basic idea of inverted index, and that is the basic concept behind full text search in Elasticsearch. So as I said before, there are several supporting tools that are associated with Elasticsearch. So these two are the two main commonly used supporting tools, Logstash and Kibana. So altogether, these three forms the ELK stack. It's kind of a commonly known. So the responsibility of Logstash is it fetches data from various sources and processes those data and send it to Elasticsearch. So it's kind of like a preprocessor. And the responsibility of Kibana is to display those information and allow the user to create various kind of analysis using those data, like creating pie charts, heat maps, kind of things like that. I'll show that in during my presentation, demonstration. Yeah, that's about the theory part. So I'll start the demonstration.
Is this Elasticsearch available in AWS, or is this independent?
Available in Azure as well.
Yeah, but AWS is the provider, right? Or is it an independent product that you
Yeah,
can
it's
even
an
install
independent
on your
product. I'll show that too. So here, I mean, as you asked. So we can download the zip file from here and run the whatever this.
This is because AWS also has a product they are marketing. It's also called Elasticsearch.
I think it's
also based on Lucene, but I don't think it's this product.
Maybe they are providing this as a service.
Could be that. It's as a platform as a service.
Yeah. So in order to set up Elasticsearch in your local machine, all you have to do is download this zip file from here and unzip it wherever you want. So I have unzipped it in here. So in order to run Elasticsearch, all we have to do is run this bat file, elasticsearch.bat file. So it is running in my machine, local machine. And to run Kibana as well, you have to follow the exact same steps. So to verify whether Elasticsearch is up and running, you can visit this URL, localhost 9200. It's running, so it will show it should show something like this. And yeah, this is Kibana. This is the tool. This provides an interface for us to interact with the data inside Elasticsearch. So there are several tabs in here. Discover, visualize, dashboards. I will cover these two later. And here we have div tools. So this is the one I'm going to use now. So Elasticsearch has provided us a REST API so that we can send API requests to communicate with it. So here in Kibana console, we can send API requests using this console. So I'll start with some basic CRUD operations. So here the first one is this is how you can create an index in Elasticsearch. Just send a put request. So before that, as you can see, the text index is not available right now. So I'll go ahead and create that. Now it's available. And this is how you can add a document into the index we created. So this is the document I am going to add, and this is the index name, and this is the ID of the document I am going to add. So I'll do that as well. So it has been added to the index created. This one. So for this demonstration, I have already created the index called employee data, and I will for the rest of my demonstration I will use that index. So here, okay, so I covered the creation part, and this is how you can retrieve a document from whatever the index. So you just have to send a get request with this is the index name of the index underscore doc, and this is the ID of the document I want to retrieve. This is the document I wanted, and then updating a document. So here what you have to do is send a post request to this point. Let me do that and give that back. So as you can see here, there is an issue. The original document has been overwritten by the document we just sent. So this is kind of a problem if you want to, like, let's say we want to update the one field in a document. In that case, we'll have to send all the other fields with their original values as well. So that's the issue. So to overcome that, yeah. So this is a way to overcome that. So what I'm going to do now is I'm going to update this document. So using this query, here what I'm going to do is update the eye color of this document to solid red. So I'll update it to blue. Yeah, this is what I'm going to do. So here this means take the update the eye color of document to params.value. If I retrieve that back, now it's good. So that is how we can update just one field in a document. Yeah. I mean, Elasticsearch itself is a kind of a database. Like, no. No, I don't think that can be done. We have to have those data in Elasticsearch.
Basically, you have to keep synchronizing your database
Yeah.
data with the.
That's where that logstash and there's another tool called beats. Those two comes in, yeah, because when we are writing to our SQL database, we can like maybe emit an event or something like that and send those information to you. No. The purpose of this is not to like use as a database. This is for just searching and analytics purposes. And analytics purposes.
Search.
Yeah.
Yeah, it's a different purpose of searching, right?
Yeah. Searching and analyzing data. So we should not use this as a database. Yeah, that's that. And how to delete a document? So we just have to send a delete request to this. So this is document. I'm going to delete. So retrieve it back. It's not there anymore. And query for a specific field. So let's say you want to retrieve all the employees whose joint year is 2007. So this is how you can do that. So this is the name of the index. Underscore search is a term like they have provided. So we have to use that question mark Q. So this is the condition we are looking for. Joint year is 2007. So if we do it. And this is another way of doing the same thing. In this method, we are sending the whatever the query in the request body, rather than as like this, and deleting by query. So let's say you want to delete all the employees whose joint year is 2007. So this is how you can do it. So what it does is it checks for this match condition. So the joint year matches with 2007, that particular employee will get deleted. So first right. Likewise, it's deleted. And update by query. So here as well, let's say you want to update the eye color of all the employees who joined in 2007. This is how you can do that. So all the employees that matches with this query, their eye color will get updated using this script. For now, we have only one employee who's joined here is 2007, and this eye color is green. So if I do this, now his eye color is blue. These are like pretty basic queries. And here we have a match. So what happens here is for an employee to be a valid match for this query, his address should contain Harrison Avenue or Colorado. At least one of these words. So I run this query. So we take this one. This contains all the three words. And this one contains Harrison. So it's also a valid result. So it's kind of a loose query, but if we take a match phrase, it's kind of a strict query than the previous one. So in order to for an employee to be a valid match for this query, his address should contain this exact phrase. So if we run that, it only returns one record document, and it contains that's match phrase and then match prefix. So here the name of an employee should be prefixed with Sanford name. So if I run this query, so here Sanford name, it can be proceeded with whatever the other words, other letters, but it should be prefixed with Sanford name. That's that. And query string searching. Here we can use some kind of conditions to retrieve data. So what happens in this query is the name of the employee should contain Angelina or Moss, one of these words. This one contains Angelina, and this one contains Moss. And if you put an AND condition here, it should exactly contain, both of these words, Angelina and Moss. And we can use we can do a cross field matching as well. So here I am checking whether a name of an employee, address of an employee contains Angelina or Avenue. So if we run this one, this one's name contains Angelina. If we take this one, his address contains Avenue. Likewise. And what happens in the range queries? So this query retrieves all the employees whose age is between 30 and 20 and 30. So this means greater than or equals. This means less than or equals. Yeah. We go through it. 5, 27, likewise. And then bool query. So now I'm going to construct a kind of complex query. So with these bool queries, so in order for a document to be a valid match, whatever the condition inside this bool, these parentheses should be true. So for better understanding, I'm going to do this by step. So here in this one, employee's address must contain Harrison Avenue, Colorado. If we run this, it returns 9 records. So in here, addition to that requirement, that condition, I have added another thing called filter. So I am filtering out the result set using the age of an employee. So the age of an employee should be between 25 and 38. If you can remember, previously it returned 9 records. Now it is returning 7 records. So, and in the last step, I am going to exclude all the female employees. So, in addition to the previous requirements, previous conditions, I have added another condition called this one must not. So that means the gender of an employee must not be a female. So if we do this filtering, it returns 4 records. So yeah, that is how you can create kind of a complex query using a query in Elasticsearch. Yeah, that are the queries I was ready for, and I'll walk you through Kibana now. So before doing that, I have to, before doing anything, creating visualizations and dashboards kind of things, I have to create an index pattern. So here what happens is index pattern means that it tells Kibana. So pattern can be created using one or more indexes. So it tells Kibana that these are the indexes we have to use to do whatever the analysis we want to do. So I'll show you how to do that. So, index patterns. So I'm going to create a new index pattern. So, likewise, it gives a success message saying that your index pattern matches this index. So since there are these two are sample indexes provided by Elasticsearch. So if I go ahead and type sample, so this index pattern matches with both of these indexes. So if we use this index pattern to do whatever the analysis we want, Elasticsearch will use both of these indexes to do whatever the analysis. So I'm going to use my index for the okay. Now, so I'm going to discover. So here, these are the data that are inside my index, and move into visualization. So this is kind of an interesting thing we can do with Kibana. So we can create various kind of visualizations using the data in the index. So I'll go ahead and create a, let's say I'll create a pie chart of ages of employees. So I have to select what kind of visualization I'm going to create, and the index pattern here. So what I'm going to do is I'm going to show a count of employees with their age values. So we do that like this. I mean, this is a very simple visualization. So there are two employees whose age is 39. There are four employees whose age is 25. Likewise, so this is a very basic, simple visualization. But still, we can do much more complex visualizations using Kibana. And the other thing is using these visualizations, we can create dashboards. So here, so I'll just go ahead and create a dashboard called first I'll have to save my visualization. Okay, so here I'm going to add the visualization I just created. It has been added to the dashboard. So likewise, we can create as many as visualizations we want, pie charts, heat maps, bar charts, whatever we want, and add it to the dashboard. And these visualizations will get automatically updated whenever data comes into the Elasticsearch. So this is a sample dashboard provided by Elasticsearch, guys. So I'll show you how a complex dashboard would look like. As you can see, we can create many visualizations to analyze like various perspectives of data. Things like this. Yeah. So that's about Kibana. So there are various other things. Even we can use machine learning for like analyze data as well. I haven't gone through those things because I haven't got time. So So what we can do is we can create dashboards, and like let's say a user wants to see the dash. If a user wants to see the dashboard, we can just redirect them to like post Kibana in somewhere, and we can redirect them to a Kibana dashboard. Yeah, something. So there are like various other things as well. So another thing is we can easily, they say we can do it, we can easily create a cluster of Elasticsearch Elasticsearch cluster in Azure pretty easily. And also there is a NuGet package called Nest we can use for to interact with Elasticsearch. So if someone is interested in that, they can do another tech talk on that. Yeah. So those are the things I wanted to I wanted to show you guys. So why should we use Elasticsearch? Elasticsearch like performs really fast document searching. Like if we add a document to Elasticsearch, it will take like few split seconds to index that document in Elasticsearch, and the document will get searchable after that. And Elasticsearch is distributed by nature with all the failure handling mechanisms like node shard replication. And as I told you, there are several other tools associated with Elasticsearch, like Kibana, Logstash, and there's one other thing called Beats. So these tools simplifies the process of data ingestion, visualization, and reporting kind of things. So that those tools are called the Elastic Stack. Yeah, those are the reasons to go for Elasticsearch. Yeah, that's all. Any questions? Okay.